Another night, another demo recording, and this time I get to mean it. So I have been playing whack-a-mole with context and type definition issues for the past day, but it is doing the things. So I've got this simple demo here to start with, just a little function generator with this funky looking node I've been working on. I can run this and I get this execution control interface. This is still a placeholder, but we can initialize the execution and start it running. And now I get this little function generator: square wave, triangle, saw. I'm going to play around with all of that. That's cool. It doesn't seem that cool though, because a lot going on for just this one block here. But in the tools menu, I've got my flex block tree, where I have got a handful of other blocks that I can put down. Mainly in this case, the add and the gain are the two I've created. But this will allow me to demonstrate what we're really doing with these blocks. So I'm going to take this guy, throw it over here, out of the way, and we're going to start making a little bit more room in this block diagram. So we're going to get rid of that. Now I do have these all expanded here. I do just want to show off the search functionality quick. So even with the tree, you can search for things you're looking for, but drop it down, you get another block. And there's a reason why there was some extra room up here. I'm going to create a slider to control this. So in the create submenu, you can go to channels. I do actually want this to be a writer, not a reader, so I can swap that there. And gonna throw it in here, and might as well line everything up. Gotta keep the block diagram feng shui going. And let's throw a slider on the front panel. So this is just gonna go 0 to 1, a little bit like a volume slider. And let's throw that in as that data input. And of course, let's wire up the graph output. So something that we'll want to keep in mind for this demo is this is a lossy reader, so it's got the notifier icon on the end there. This is, as I said, pretty much like a notifier, and with the graph right in here. As I'm dragging this slider around, it is gonna look like it's hiccuping, but that's because this is allowed to skip entries as it needs. But now I can run this. Let's go ahead and save it. I can run this again, get my execution control now, and now we see I've got a function gen and a gain block. So initialize them, they both initialized, and run it. And now I've got a slider to control that gain. So go ahead and stop that, and let's throw in one more for this demo. Let's throw in this add, and I am going to just create a copy of these guys. We'll make this one go from -0.5 to 0.5, and we'll throw that right there. So making a little bit more room again. Now it's probably still not obvious yet why this framework uses channel wires and does some of the automatic code generation it's doing, which we'll take a look at in a second. Oh, come on, hook up with the terminal. There you go. move you down a little bit. Get this stop wire out here. No, that's not what I wanted. I wanted to click the border of it and move it. There you go. So now I can run this again. Init, run. We've got the add, the function generator, and the gain. And I can do all sorts of fun offsets, change the gain. And if it's not apparent from these iteration counts and the run counts, these three blocks are running in parallel. So you get to lay out your processing functionality as if it was regular data flow, but these do all run in parallel, passing their values through these channel wire connections. So if I go ahead and close this, one of the edit time functionalities that I've built for this is if you double click these nodes, you are brought to the block implementation. So here we can see the function generator just pre-calculates some values it's going to use for doing the function generation, and then it just uses the simple waveform generation sub-VI that ships with LabVIEW, adapts to its types from our simpler names, but calculates that, changes it to the cluster style waveform instead of the actual waveform data type, and sends it on out. There are no channels in use on these sub-VIs. And what else this does is these categories that are listed in the block tree are specified in the VI's description. Just anything in square brackets, comma separated names will be the categories it gets thrown under in the block tree. Also, with the block tree, if you look at the description is pulled out here, of course it strips out the category tag, but we can see that all in here along with their icons and all their names and everything. I can also open the entire library from this block tree editor. So if I wanted to come in and edit some data types or edit the functionality, I can get to that very easily from this. If I wanted to create a new one, I get the new VI wizard, the new block wizard. I could give it a name. And you can select from these states to get started, whichever ones you think you'll need. These are just case structure selections in the work VI of the block that's created, the block library. And if you need to change the action diagram in the future, you could just add or remove cases as necessary. And then another feature that will be that is available actually is I/O control, where you can skip outputs or skip inputs, set timeouts on the inputs. So if you have something that you're trying to stream data to, and you want to keep that stream fed, even though data might be delayed getting to that block, you'd be able to set a timeout, and then you could use default data if that did in fact time out. But we're going to go ahead and not create one yet. But yeah, so these all run in parallel. This would be a pretty easy way with very simple code in some cases, just to multiply here, to get data processing done in chunks in parallel, and the flexibility to move things around. Let's say I didn't want to, or let's look at another intermediate set of data. I want to do some debugging and see what's happening in the middle of this chain. Let's say these were more complex than just a multiply and an add, and I wanted to see what's going on in here. This wire type is branchable, and you can just tack things on where you want to. So now if I run this, still have the same three blocks, initialize, run. Eventually the execution control will get a little bit more automated. This is the development interface for now. But now I can see in this one, we're seeing it after we apply the offset, but the bottom chart is only for the gain. So you have the flexibility of just tagging on and peeking at what's going on at intermediate locations. And if I wanted to ignore both the gain and the add, just maybe preview the source data, Again, we'll go ahead and do that. So now the bottom graph isn't looking at either the gain or the offsets being applied. You just have a lot of flexibility in seeing where you're looking at values for.